Greetings from the Department of ECE, SJBIT. In this session, we will be learning about microwave passive devices and network theory, of which is a module 2 in the course Microwave and Antennas. So, in module 2, the first part, we will be learning about microwave network theory, and here uh, the symmetrical Z, Y, and ABCD H parameters for the reciprocal network and S matrix representation for two-port and multi-port network will be continued, and the properties related to that. Then the relationship between Z, Y, and S parameters will be considered. In the passive devices, you will be learning about coaxial cables and connectors, attenuator, uh, phase shifters, and waveguide T's, E plane and H plane T, and magic T. And as we know, before we start with the coaxial cable, we know in the first module, as we had seen, the type of it is a type of transmission line uh, which is used for transmitting a signal from one point to another point. A coaxial cable is the one which will transmit the signal from one point to another point. In the same manner, you have a two-wire parallel transmission line, strip line, and microstrip line, waveguides. So we will be looking at coaxial cable in this class, that is the coaxial cables and connectors. uh, as we know, transmission line are the one which is used to transmit the energy from one point to another point, and it can also be used means different types of transmission lines that you have are two-wire parallel transmission line, you can observe here, and coaxial cable, strip line, microstrip line, and the waveguide. And now we will be looking into the coaxial cable. You look at the structure of a coaxial cable. You have two conductors which are separated by a dielectric material. So inner conductor and the outer conductor. So outer conductor, which is like a wire type mesh, wire mesh type braid, we call it as. Upon that, we will be having a plastic jacket. So the dielectric material, each dielectric material, as we know, we have a dielectric constant which is a epsilon r value, relative dielectric constant, epsilon r value. And as we know from the concept of two conductors which are separated by dielectric, which will act as a capacitance. Once if the current enters through that structure, due to the magnetic field, inductance will also be generated. And the inductance, the empirical formulas for capacitance and the inductance relating to the diameters of outer and inner diameters of outer diameter of the inner conductor and inner diameter of the outer conductor relating, which is shown here. So C is equal to 2 pi into epsilon naught epsilon r, so which represents 2 pi epsilon divided by ln of d by d, capital D indicating inner diameter and small d indicating outer diameter of the inner conductor. Similarly, L value, which is 0.2 ln d by d, which is in microhenries per meter. So all these values, as I have specified in the first module, they are measured per unit length. Then Z0 value, characteristic impedance of this cable, if I want to evaluate, which is nothing but square root of L by C under the lossless condition. You substitute the value of L and C, which we have got here, into this expression, which leads to the Z0 value as 60 divided by square root of epsilon r into ln of d by d, which is again it is a measured per unit length, ohms per meter. So for example, for one cable like RG58C or U cable, universal indicating RG radio guide, type of the cable which they are specifying, that coaxial cable, in the data sheet they will be specifying small d and capital D, as well as the diameter epsilon r value. You can observe 0.91 mm and 2.95 mm, which has been given small d and capital D, with epsilon r value as a 2.1. You can evaluate by substituting into the above equation, gives you the characteristic impedance as 50 ohms, around 50 ohms. So in the similar manner, if they give uh, the specifications, you need to refer to the diameter, inner diameter and outer diameter, followed by the frequency range of operation and the capacitance and inductance values, characteristic impedance of that value you can see from the specifications. Epsilon r value also to be verified. Then in the same manner, there are some of the coaxial cables which has different type, which is as I specified, RG indicating RG type, radio guide type, and universal with different numbers, which has been specified with their characteristic impedance. And for inner and outer conductors, the type of material which they have used based on that, and even the diameter particular to the specifications, the Z0 value will be varied. You can observe here the different types of coaxial cables. And main drawback in the coaxial cable is you have an attenuation. So the attenuation, which is usually measured in terms of decibels per length, per unit length, or per meters, with respect to the frequency. So if you observe the different types of coaxial cables, you can observe the attenuation of the signal, which is varied from 40 dB to 90 dB if you operate the coaxial cable from lower frequency to higher frequency, from 500 megahertz to up to 2 gigahertz if you operate RG58U. If you consider, the attenuation value has been increased from 40 dB to almost 80 dB. So in the same manner, before you choose the type of coaxial cable, you need to look at the frequency of operation, frequency range, and followed by the attenuation. So in the same manner, if you look at the next one, which is connectors, so these are the one which they will make use to connect the microwave or microwave power from one point to the another point, to connect your microwave network to your generator or oscillator or amplifier. To connect between the 2 points, you will be using the connectors. So there are different types of connectors, and before you go for the type of connector, one thing you need to remember is the frequency of operation. So BNC cable, if you observe, which is both the male type and female type were available, which can be used up to 1 gigahertz, and N type N type male and female. And here you can observe the device, it's a connector model, which can be used up to 4 gigahertz, and APC SMA sub-miniaturized version A can be used up to 18 gigahertz, and K type connectors, we have a male and female again, and can be used up to 40 gigahertz. And here you can observe different frequencies, different connectors and their frequency range. Similarly, the same thing, what is that N type indicating a Navi type, and BNC indicating bayonet Navi connectors and threaded Navi connectors, sub-miniaturized version A, which is SMA connectors, APC amphiolion precision connectors. These are the connectors which we will make use in RF frequency range, that is in the microwave range, specified with their dielectric material used and along with the impedance and their frequency range. N-type connector with a AR as a dielectric media, available with 50 ohm impedance and 75 ohm impedance, and can be used up to 1 to 18 gigahertz range. Similarly, the other materials, other type of connectors also. Then this is a diagram which is depicting different types of connectors. N type, Navi type, male and female, BNC type, male and female, TNC type, threaded Navi, and SMA connectors, male and female, even BNC type, TNC type, SMA, APC, and N type of APC. Different types of connectors, how it looks like, you can observe from this, and their dielectric material along with the impedance. And next type of passive devices, next type of a device which we will look into is a waveguide transmission media, which we will look into as a waveguide. Waveguide is nothing but a hollow structure which can be used up to which can be used to transmit the signal from one point to another point. They have a pipe like structure where the waves will be propagated by hitting the walls. So you have a different types of waveguides like rectangular, circular, elliptical, and they can be rigid and flexible available. And waveguides they have a very low loss compared to the other transmission medias. And here you can observe this is a rectangular waveguide, hollow structure, circular waveguide, and elliptical waveguide. And how the wave will be propagated, you can observe the propagation of the wave within the waveguide by hitting the walls. By hitting the walls, the waves will be propagated in the waveguide. And if you look at the mode of operation, so wave propagation will be specified in different ways. So the time taken to move down the guide varies with respect to this mode, and each mode will have a cutoff frequency. So below that cutoff frequency, it will not be allowed. The signal will not be allowed to propagate. So we specify a mode as the one with the lowest cutoff frequency. We call it as a dominant mode. A mode with the lowest cutoff frequency, we call it as a dominant mode. And here you can observe the lower order and higher order modes, how the waves will be propagated waveguides, and different types of modes which are supported by this, which are propagating in the waveguides are TE mode, TEM mode, TEM mode. So indicating transverse electric, transverse magnetic, and transverse electromagnetic. So transverse electric is the one electric field which is right angle to the direction of propagation, and TM mode magnetic field is right angle to the direction of travel, whereas TEM wave indicating that transverse electromagnetic direction of propagation is right angles to the electric and magnetic fields. And we also say that these are the waves which are propagating in the free space. And the rectangular waveguides, if you observe, why we are studying means in the next portion you need to look at the rectangular and circular waveguides. So you need to know the minimum concept. So the rectangular waveguides, if you observe, the dominant mode in rectangular waveguide is a TE10 mode. 10 indicating for a rectangle you have a length and a longer dimension and shorter dimension. Longer dimension is represented as A and shorter dimension considering as B. So 10 indicating you have a 1/2 cycle variation along the long dimension, and 0 indicating there is no half cycle variation along the shorter dimension. So coming to the cutoff frequency, usually the cutoff frequency, which is a lambda c by a value, you need to choose as a lambda c by 2. And the modes with the higher cutoff frequencies, this is a dominant mode, as I have specified, it is the mode with lower cutoff frequency. So higher cutoff frequency modes will also be generated in the rectangular mode, like TE1001 and TE20 and so on. So to understand the concept easier manner, you can observe a longer dimension is A, shorter dimension is B. So 10 indicating along the longer dimension you have a half wavelength variation. Along the shorter dimension there is no variation. So in this case you observe 20, so two half waves along the longer dimension. No variation along the shorter dimension. And TE11 mode, it is the dominant mode in circular waveguide. You can observe half wavelength along the longer dimension as well as shorter dimension. So quarter together half wavelength. Similarly, the other one you can understand. So the cutoff frequency usually which is specified for a rectangular or cutoff frequency for any waveguide, it is the one with which below which the frequencies were not allowed. If I want to operate the rectangular waveguide, you need to give a frequency greater than the cutoff frequency. For TE10 mode in the rectangular waveguide, by choosing A value is equal to 2B, you will get the cutoff frequency as C by lambda. Lambda is a 2A. Here you can, as you are choosing that. For example, if I consider a waveguide which is of RG50 to U, with their internal dimensions specified as 22.9 by 10.2, indicating A and B values. So usually they'll specify the cutoff frequency. Cutoff frequency of that is 6.56 gigahertz. That means usually it is the minimum frequency. Uh, uh, if I want to make use that use that waveguide, I need to make use beyond that. So you need to make use that beyond your 6.56 gigahertz, which is from 8.2 to 12.5 gigahertz. Uh, so in today's session, we have learnt about the coaxial cables, different types of how to evaluate the characteristic impedance Z0 value, and different types of connectors, N type, TNC type, BNC type, and different types of connectors and their frequency ranges. Then followed by another type of transmission media, which is a waveguide, and different types in that: rectangular, circular, and elliptical. Then followed by the rectangular waveguide, dominant mode definition. Then followed by how to means how to identify the mode of propagation in a waveguide. Then followed by an example and the cutoff frequency definition. Okay, thank you. Next class, the next session, we will learn about the attenuator, fixed and variable attenuators. Thank you.